Dear students, this lecture is about the introduction of vectors. This topic has been studied in your previous semester. These topics are the same topics which we have studied in your first semester. So let us start the lecture. First of all, we need to define a vector. That what is a vector? So obviously vector is a quantity, a physical quantity which has two things. The first one, magnitude, which is actually the length of that physical quantity, so the length, and the second one is the direction. So a physical quantity which has these two things, I mean length and direction, that quantity, that physical quantity, is called a vector. Now vector is always represented by an arrow. We represent a vector by an arrow. The length of the arrow, the length of the vector actually, is the magnitude, and the arrow is the direction of the vector. For example, if a particle is moving along a straight line from a point A to a point B, and that is physically drawn in this fashion, a particle is moving from point A towards point B. So this movement is represented by this vector AB, which is denoted by V. So this is called the displacement vector. This displacement vector V is represented by AB vector. This vector V is represented by AB vector, that is the starting point of the vector, and that is the end point of the vector. Now this starting point of the vector is called the initial point. This point is called the initial point of this AB vector, or we may say that this is the tail of this AB vector. And secondly, this point B is called the terminal point of this AB vector, or we may say that that is the head of this vector AB. Similarly, we have a well-known rule which is called head to tail rule. What does it mean? For example, we want to reach from point A to point C, or we may say that we want to start our journey from place A to place C. So that is the displacement vector for that one. But if you are going to from point A to point C, and there are hurdles in this area, and there is a route from point A to point B, and then from point B to point C. So if you want to get AC, this AC, so first of all you need to go from point A towards point B, then from point B towards point C. So you see that this AC vector has tail which is on point A, and has its head which is the head of this C. So we may say that we need to, if you want to get AC vector, you need to join the tail of A to the head of B. That is the tail of A, actually that is AB, the tail of AB, and that is the head of BC vector. So mathematically AC vector is equal to AB vector plus BC vector. AB vector plus BC vector is equal to AC vector. And if this figure is not known to you, if this figure is not given to you people, then still you can use head to tail rule by considering this sum. We see here that b is repeating here, so dropping b you'll get AC vector. So that is actually head to tail rule. The third one is a unit vector. So unit vector is that vector whose magnitude is 1. We may say that magnitude of 1 meter, or we may say magnitude of 1 kilometer, whatever your what are the units which you are going to use for calculation. So unit vector is a vector whose magnitude is 1, and from here we have got x-axis. So unit vector in the direction of x-axis is denoted by I cap, and unit vector in the direction of y-axis is denoted by j cap, and unit vector in the direction of z-axis is denoted by k cap. Unit vector is usually denoted by caps, by putting a cap on the head of that number, that letter. So caps are used for unit vector. So these are the three unit vectors along the coordinate axis: x-axis, y-axis, and z-axis. The fourth one is the components of a vector. For example, if we see here, that is a 2D vector, because this is this vector is on the wall, on the plane, xy plane. So this vector has two components: the component along x-axis, which is a1, and the component along y-axis, which is a2. So this vector a, which is actually a 2D vector, has two components: the component along x-axis a1, comma, the component along y-axis, which is a2. Similarly, if you consider a 3D vector which is in your room, a 3D vector, this 3D vector has three components. The first component is along x-axis, which is a1, and the second component is along y-axis, which is a2, and the third component is along z-axis, which is a3. So this vector a, which is a 3D vector, is representing an order triple notation, and this 2D vector is representing an ordered pair notation. So a 2D vector has two components, a1, a2, and a 3D vector has three components, a1, a2, and a3. Now for 2D vector has actually two components. So I is actually a unit vector in the direction of x-axis. So in the direction of x-axis, the component of I is 1, because that is a unit vector, and along y-axis its component is 0. Now j cap is actually a unit vector in the direction of y-axis, and on y-axis x is 0, and the component of j along y-axis is 1, because that is a unit vector in the direction of y-axis. Now for 3D vectors, I cap has a component 1 along x-axis and 0 on both the y and z axis. Similarly, j cap is a unit vector along y-axis, so its components along x and z axis are 0, and the component along y-axis is 1. And the same for this k cap. The components along x and y axis for k cap are 0, and the component along z axis is 1. So these things are familiar to you people, that what are ij and what are ijk in 3D notation. We have got notations for vector. That is the first notation, which is called ordered pair notation. and that is the ordered triple notation for a vector. We can denote these two vectors instead of ordered pair and ordered triple in IJK notation. For example, this vector A, which has ordered pair notation A1 comma A2, this can be written as A1 into I cap, which is the unit vector in the direction of x-axis, plus A2 into unit vector in the direction of y-axis. Similarly, a 3D vector, this 3D vector can be written in the form of ij notation as A1 into I cap plus A2 into j cap and A3 into k cap. So that is the second notation for 2D and 3D vectors. In this slide, we will study about how to find a vector when head and tail of a vector are given. For example, there is a vector AB. Its tail is a point, actually a 3D point, if this vector is a 3D vector, and if this vector is a 2D vector, so this tail will consist of two numbers x1 y1. So there is a vector which is actually in the space. Its tail is A, which has three components x1 y1 z1, and that head, which is B, it has also three components x2 y2 and z2. If you want to find this AB vector, so this AB vector will be obtained by subtracting A from B. We can say that AB vector is obtained by subtracting tail from head. You see here, subtracting this tail from this head. Or we may say that AB vector is equal to B minus A, second minus first. So B minus A is actually x2 minus x1, comma y2 minus y1, comma z2 minus z1. So that is actually AB vector, and this definition is for question number 9 through 14 of exercise 12.2. So that is actually question 9 through 14. We are asking to find a vector AB, and in question number 9 we are given the tail of AB vector minus 2 comma 1, and the head B is 1 comma 2. It means that is a 2D vector. So how could we find AB vector? By this definition, AB vector is B minus A, so this B minus this A. So how could we subtract these two ordered pairs? First minus first, just look at that, first minus first, comma second minus second, second minus second, minus minus plus, so 1 plus 2 is 3 and 2 minus 1 is 1. So that is your AB vector. That is a very simple topic. Now question number 13, instead of 2D points we are given 3D points, so that will be a 3D vector, AB vector. How could we obtain AB vector? By that definition, B minus A, so that is B minus that is A. Subtracting these two ordered triples, 2 minus 0, comma 3 minus 3, comma minus 1 minus 1. So subtracting these numbers, 2 minus 0 is 2, 3 minus 3 is 0, and that is minus 2. So that is AB vector. So that's how we find a vector when 2 points are given, or we may say that when the head and tail of a vector are given. On this slide, we will be studying the sum and difference of two vectors. The sum and difference of two vectors is not defined mathematically as such as we consider numbers, but that is actually the resultant of the vector. Anyways, how could we find the sum and difference of two vectors? And this topic is for question number 15 and 18 of exercise 12.2. For example, we are given two vectors, vector A whose components are a1, a2, a3. This vector may be 2D vector a1, a2, but we are considering here order triple a1, a2, a3. Similarly, a second vector B is given to us, b1, b2 and b3. How could we find the sum and difference of these two vectors? This is a very simple topic. We just need to add or subtract the corresponding components. Addition and subtraction of first components, comma, second components, comma, third components. So that is the summation, or we may say sum and difference of two vectors. Now question number 15 through 18, we are asking about find the sum of the given vectors. Question number 15, we are given two vectors, -1 comma 4, and that is 6 comma -2. These two are actually 2D vectors. So first of all, we name these two vectors. There is a vector A and there is a vector B. Now the sum, we just need to find the sum. The sum of these two vectors A plus B is equal to this vector plus this vector, and that is equal to, by this definition, first plus first, comma, second plus second, and that is actually 5 comma 2. So A plus B is 5 comma 2. This A plus B, which is 5 comma 2, is the resultant of vector A and B. Similarly, considering a 3D vector, two 3D vectors, this and that, giving the names for these two vectors, there is a vector A, there is a vector B. Now A plus B is equal to this vector plus that vector, and this equal to first plus first, comma, second plus second, comma, third plus third. Now adding these numbers, 3, 8, 1 is A plus B. So that's how we add two vectors. In this slide, we are going to study about the magnitude or length or norm of a vector. These three are the names of a single person: magnitude, length and norm of a vector. And this topic is for question number 19 through 22. Let's say we are given a vector A whose components are a1, a2, a3. This vector may be a 2D vector. So the magnitude of this vector A is denoted by absolute A, magnitude of A. Or we may write the magnitude of A by removing this arrow from A to get A. So simple A can be used for magnitude of a vector. So the magnitude of this vector is denoted by this symbol or that symbol, and that is given by the square root of sum of the squares of the components. Square root of the sum of squares of those components, that is square root of a1 square plus a2 square plus a3 square. So that's how we find the magnitude of a vector, that is the length of that vector. Now number 8, that is actually a topic, scalar multiple of a vector, and this topic is for same questions, question number 19 through 22. What is a scalar multiple of a vector? For example, we have got a vector A whose components are a1, a2, a3, and k is any scalar number. K is any scalar number. Scalar is that quantity which is not zero, that may be positive or negative but not zero. So whenever we multiply this k with this vector A, so that will be equal to ka is equal to k times this vector, and this k, which is a number actually, will be multiplied with all these components, just like that. So that is called the scalar multiple of a vector. Now welcome to those questions. Question number 19 through 22. We need to find a plus b. We need to find 4a plus 2b. We need to find the magnitude of a, and we need to find the magnitude of a minus b. The sum of two vectors has been studied. The scalar multiple. So let's start from question number 19. We are given two vectors. Those are actually 2D vectors. Vector a, which is minus 3 4, and vector b, whose components are 9 minus 1. We are going to find a plus b, 4a plus 2b, magnitude of this a vector, and magnitude of a minus b vector. So first of all, a plus b vector is a vector plus this b vector, and that is actually minus 3 plus 9 comma 4 plus into minus 1. Minus 3 plus 9 is 6, and 4 plus minus minus 4 minus 1 is 3. So that is actually a plus b. Now 4a plus 2b, 4a plus 2b is equal to 4 into a vector plus 2 into b vector. So that is b vector. Now that is the scalar multiple of a, this topic. So multiply this 4 inside. 4 3s are minus 12, and 4 4s are 16, and that is the scalar multiple of b. 2 into 9 is 18, and 2 into minus 1 is minus 2. Now that is the addition of these two vectors in the same process. Minus 12 plus 18 comma 16 plus into minus 2. Minus 12 plus 18 is 6, plus minus minus 16 minus 2 is 14. So that is 4a plus 2b. Now how to find magnitude of a? Using this definition, magnitude of this a vector. Magnitude of a vector is equal to the square root of minus 3 whole square plus 4 whole square. Minus 3 whole square is 9, 4 square is 16, 9 plus 16 is 25, and the square root of 25 is 5. So that is the magnitude of this a vector. Now we need to find the magnitude of a minus b. For magnitude of a minus b, first of all we need to calculate a minus b, and then taking the magnitude of a minus b. So a minus b is equal to this a vector minus this b vector, that is minus 3 minus 9 comma 4 minus into minus 1. Minus 3 minus 9 is minus 12, minus minus plus 4 plus 1 is 5, that is a minus b vector. But we need to calculate the magnitude of a minus b. So the magnitude of a minus b is the magnitude of this vector, that is equal to square root of minus 12 whole square plus 5 whole square. Minus 12 whole square is 144, 5 square is 25, and that is equal to 169, and the square root of 169 is 13. So that is the magnitude of a minus b. So how could we add two vectors? How could we find the scalar multiple of vectors and the magnitude of vector? Those are being studied in these questions. Now in this slide, how could we find a unit vector? Unit vector, remember that. How could we find a unit vector in the direction of a given vector or parallel to a given vector? Let's say that is a vector a, then unit vector in the direction of this vector or parallel to this vector is given by unit vector is denoted by a cap. You can denote this by n cap, whatever the letter is, but that vector is a, so that's why we have denoted this unit vector by a cap. So this a cap will be equal to this vector a divided by its magnitude. So whenever we find the unit vector which is in the direction of a given vector or which is parallel to a given vector, will be obtained by this formula, that we will divide that vector by its magnitude. So vector by its magnitude is actually what? Unit vector in the direction of that vector. And that is for question number 23 through 25. Find a unit vector that has the same direction as the given vector. Question number 23, we are given a vector 6 comma minus 2. We need to find a unit vector in the direction of this vector. So first of all, we denote this vector by A, or you may denote this vector by B. So that is A vector. For unit vector in the direction of this A vector, we need to find the magnitude of the vector. So the magnitude of this vector will be equal to square root of 6 square plus minus 2 whole square. 6 square is 36, and that is 4, and that is square root of 40. 40 may be written as 4 cross 10, and the square root of 4 is 2, and that is the square root of 10. So that is actually the magnitude of this vector. So therefore unit vector in the direction of this vector is given by this formula, that the same vector by its magnitude. The vector is actually 6 comma minus 2, and its magnitude is obtained 2 into square root of 10. Now this will be divided by 6 and minus 2 as well. So 6 by 2 into square root of 10 minus 2 by 2, 2 to cancel, 2 ones are 2, 2 threes are 6, so that is 3 by square root of 10, 2 to cancel, so that is 1 by square root of 10. So that is a unit vector which is in the direction of this vector A. Similarly, in question number 25, another notation for a vector is given, that is IJ notation. We denote this vector by A, and first of all we will write this vector in ordered triple form, minus 5 comma 3 comma minus 1. So that is the ordered triple notation for this vector. Now in the same manner, we will calculate the magnitude of this vector A. So the magnitude of A is minus 5 whole square plus 3 whole square plus minus 1 whole square, and calculating minus 5 whole square, which is 25, that is 9, and that is 1, so that is square root of 35. Square root of 35 cannot be simplified more, so we will leave this number right here. That is the magnitude of this vector A. So the unit vector in the direction of this vector A is vector A by its magnitude. Vector A is this one, and its magnitude is square root of 35. You can write this vector in IJ notation as 1 by square root of 35 is common, and that is minus 5 into I cap in this notation, plus 3 into j cap, minus 1 into k cap. So that is a unit vector which is in the direction of this A vector. So that's how we find a unit vector in the direction of a given vector.